Hi, welcome to 5.2 angle bisectors and perpendicular lines. So an angle bisector is a segment, ray, or line that separates two halves of a bisected angle. So what that means is basically you're cutting angles in half. In order to do that properly, you're supposed to use a compass. We're not making that mandatory for this. So basically all you need to know is that a bisector cuts an angle in half. Okay, so bisector, cut angle in half. So in other words, you're just dividing by 2. And the other part of the title there is perpendicular lines. And a perpendicular line are two lines that form a right angle. So perpendicular lines cross at such an angle that they make the square angle. So we would say these two lines here are perpendicular because they meet at 90 degrees to each other. Alright, and here's a couple examples of bisectors. Okay, here a line has been bisected, so cut in half. And here an angle has been cut in half. So you can bisect lines, you can bisect angles, and the word bi literally means two. So I think about a bicycle, 2 wheels. Okay, biathlon, 2 sports. So here bi would be bisect, so to cut in half. So in order to bisect an angle, you're just going to use your protractor, measure the angle, divide by 2, and then you're off to the races. So let me just drop a protractor onto the page here. Okay, so let's measure this angle. Okay, so I got my protractor on the vertex, got the 0 lined up on the first ray. Okay, you can see I'm starting at 0 right on the ray. You can see I'm right on the line, counting upwards to there. So 35 is halfway, so it looks like 36 right on that line right there. So if you cut 36 in half, you get 18. So that would be 15, 16, 17, 18 right here. That's our 18 degrees. So now all I would do is get my protractor out of there. Just erase some of this stuff. And take out my straight edge, which can be anything, a ruler or a compass, pardon me, a ruler or it's like even a ID card in your wallet, like a bank card. Just need to draw a straight line through that point. Okay, so now we have the larger angle bisected. So here's 18 degrees, 18 degrees, and we know that the original angle was 36 degrees. So not too hard with the protractor. So it starts off with builder skills number 1. If a right angle is bisected, what is the size of each angle? So I'm just going to sketch in a right angle. It doesn't have to be perfect, your sketches, but should be similar. So you know that a right angle is 90 degrees. So if we were to bisect that, we're talking about cutting that right in half, and I can estimate that pretty well with my iPad here. 90 divided by 2, 45 degrees, so from there to there is 45 degrees. From there to there is also 45 degrees. So they want you to bisect the given angles using a straight edge and compass, so you can just use a straight edge and protractor. I'll do the first one for you. I did it on the previous page as well. So let's do I'll do this one in the middle. So you can see that the protractor is saying that it's just before 90, so probably like 89. So 89 is an odd number. So when I divide that by 2, I'm going to get a decimal. And so the decimal you're going to have to approximate on the protractor. 44 and a half. So 44 and a half would be somewhere in between 44 and 45. So I just drew a point right here. Now I'll take my straight edge and connect to that spot. And of course, you can see my iPad app is not letting me hit that spot, so we'll have to just leave it as is. Get this out of the way. And you can see that this is approximately 44 and a half, 44 and a half. So similar to the one we just did. So practice on A and C, bisecting angles with straight edge and protractor. Okay, number 3. Now we have like a word problem. It says an angle is bisected. Okay. Each resulting angle is 78. How big was the original angle? So if we let come on computer, there it is. If we let x be the original angle and we have to bisect it, then x divided by 2 results in 78. So then if we think about this equation, some angle divided by 2 is 78. So basically what we need to think of is a number that's twice as big as 78. Because in order to solve for this, we're going to have to do the opposite of dividing by 2, which is timesing by 2. So this is a little bit of algebra. Whatever you do to one side, do to the other. So divide 2 times 2, that's 1. They undo each other. So you've solved for x on the left side. And 78 times 2 is 156. So there's the original angle. Now number 4, it's very similar but a little bit more challenging. It says the size of one resulting angle after the original angle is bisected is equal to the supplement of the original angle. So number 4 is quite challenging in the sense that you have to build an equation from the words. So let me help you with this. So it says the size of one resulting angle after the original angle is bisected. So again, let's let x be the original angle. So x divided by 2, and I'll use a different notation than what I used above, just because there's going to be more information on the equation. So the original angle is bisected, and it says it's equal to the supplement of the original angle. So the supplement of the original angle is 180 take away x. Now then it says what is the measure of the original angle, which is x. So here we have to solve for x. Now in order to do that, we're going to have to multiply both sides of the equation by 2 in order to get rid of the 2 in the denominator on the other side here. So let's put a 2 here and a 2 here. Those 2's will cancel so that we can isolate x on the left here. Now when you multiply 2 on this side, you have to distribute. So distribution. Now to solve an equation like this, you need to have the x on one side and the number on the other. So what I'll do is I'll add 2x to both sides. That will get rid of this. Now on the left we have x plus 2x, which is 3x, and 360 on the right. Finally, divide by 3 to solve x, 120. So quite a challenging question, because A, it's hard to even set up the equation, and it might even be challenging to solve an equation like this. So very challenging. And you won't typically see questions like this on my exam. They're too hard. Maybe you'd have one like this at most. Okay, so now they're wanting us to use a protractor to determine whether angles are perpendicular or not. So all you have to do is overlay your protractor onto these and see if it lines up with 90. Now you know that 90 is the square angle, so it lines up perfectly with this tool. So you can see that this angle down in the corner, it's a little bit off, but I would say that it's the closest one to 90. This one's quite a lot off. Oh, this one looks pretty good too, but it's sort of tailing to the right. So really I don't think any of these angles are 90. They all seem to sway off the 90. Alright, number 5, it says a crooked table leg makes an angle of 86.7 with the tabletop. How much must the carpenter move the leg so that it becomes perpendicular? Well, we know in perpendicular is 90, and it's at 86.7, so it's very close. All you have to do is subtract. So 3.3 degrees more, and it will be at a right angle. At what approximate angle does the hill incline from the horizontal? So this is probably where they want us to approximate. So I'll draw in the right angle, because that's very easy to do. And you can see that the angle of the hill is roughly coming halfway, which bisects the 90. So I would say that this is roughly 45 degrees. Now we can get into the last question, number 7, about a carpenter and laying different types of wood on a tabletop. And it says, what must be the size of angles A, B, C, and D? Okay, so we need to remember about complement, supplement, and triangle angle sum. So for complement, 2 angles add to 90. For supplement, 2 angles, or all the angles would add up to 180. And triangle, again, all the angles have to add up to 180. So for the first one, A, you can see that a straight line is made with all 3 of those angles. So 60 plus A plus 75 equals 180. To solve for A, we have to subtract 60 and 75 from the other side. And A will be 45 degrees. It's the exact same process for B. So I'll just do that quickly. 180 minus 75 minus 55. So B is 50. And now for C down in the corner, if I know that 2 of the angles in a triangle add, and I just need the third, again, all I have to do is subtract from 180 because I'm going to use this rule here, the triangle angle sum. So for C, all I do is start at 180 and subtract the other 2. So 180, take away 75, take away 50 is 55. So I got C there. Now all I need is D. D right here. So again, I will use the fact that all 3 angles in a triangle add up to 180. So starting at 180, subtract 75, and you will solve for D. And that will equal 30. So D is 30 degrees. And make sure you know complement, supplement, and the triangle angle sum. And this section should go okay. And here's your homework for section 5.2.